Hey guys, we're back with the notes for 9.3. Here's what I'm going to ask you to do. If you would, pause the screen, go ahead and copy what you see. Actually, let me screen that out just a little bit. Pause the screen, copy what you see, and then we'll get started. Perfect. All right, hopefully if you have this written down, you'll notice that I'm going to show you in Desmos, the online calculator, exactly what's being talked about on this screen. All of these are going to take the parent function, that's my x squared, and they're going to edit it. We might be making a change after the squared. We might be making a change in the parentheses before the squared, or we might be making a change out in front of the x. I'm going to use those same colors on the graph to show you what I'm talking about, okay? All right, so if we use this is my parent function. Adding a number after the squared or subtracting a number after the squared. Let me click on this one. If I add a number after the squared, so plus 2, maybe I do plus 3, plus 4, plus 5, what that does is it moves my graph up that many spaces. It takes the 0, 0 vertex and it moves it up. If I subtract a number from my vertex or from my equation, it's going to take me down that far. So if I do minus 3, it goes down 3. Minus 4 goes down 4. Minus 1 goes down 1. That's what the blue at the end of the equation does. Anytime I add or subtract a number after the squared, it's going to move me up and down. Let's talk about what happens if it goes in the parentheses. Inside the parentheses, let me show you in red. I call these the liar equations. The way I say it is if I was stuck in a room with my x, they would lie. If I was trapped in that parentheses with the x, that 2 is going to lie to me. If he says he's a minus 2, what it really means is he's going to plus 2 over here. So if I type in a minus 3, he's going to plus 3. If I type in a minus 5, he's going to plus 5. Let's talk about the other one then. So that means that if I type in a plus 2, he's going to lie to me. He's actually going to go negative. Okay, so if I do plus 5, it's going to move left 5. Plus 1 is going to, it's going to move us left 1 space. That's what the inside does. It lies to us, and it moves left and right, the opposite of what it says it's going to do. Okay? All right, anything out in front, a negative, a 2, or a 1/2 is not going to change our starting point. It still means that we're going to start off at that point 0, 0. But what I'm going to do is change the shape of the graph. So watch what happens if I take my parabola and I just put a negative in front of it. Same way like first semester, if you made a negative slope, it flipped it upside down. That's what we're going to do. If you see a negative out in front of your equation, it's going to flip the graph. Okay? Let's talk about what to do if I make a 2 inside. If I put a 2 in front. If I put a 2 in front, it's going to go up twice as fast. See how it gets really skinny? Let me move this down. It's going to make my graph really skinny. It's twice as skinny. That means if I put a 3 in here, it'd be 3 times as skinny. If I put a 5 in here, it's 5 times as skinny. It's going up 5 times as fast. So the bigger that number gets, the skinnier it gets. We will not use anything other than a 2 for right now. So at 2, you would say it makes it narrow. So if a 2 makes it narrow, what do you think a half does? If it's going up half as fast, that's going to make it fatty. It's going to make it what we call wide. So the smaller my number is, like a 1/2 or 1/4 or 1/5 or 1/10, that's going to make my number or my graph wider. We will not use anything other than a 1/2 in this section. Okay? All right, I'm going to go ahead and exit out of Desmos. And let's go ahead and look at our notes here. All right, so moving down here, hopefully you wrote this down. I want to talk about the pattern. You're going to be responsible for identifying all of the changes, so the green, the red, and the blue, but you're also going to be responsible for graphing without a calculator. Yes, I said that. If you're in person, we will take this quiz without a calculator. If you are taking it online, know that your quiz is going to have questions that you cannot even solve in Desmos. It's going to be asking you to describe how you would graph it. You will not be able to type them in. I'm going to do it without numbers, okay? All right, so let's talk about that pattern then. In my pattern, you are going to need to remember all your squared. The pattern is called 149. You're going to have that memorized. Here's how it works. If I start at the vertex, wherever my vertex is, you're going to think out and up. 1 square out is going to be 1 square up. So 1 squared is 1. If I go 2 squares out, 2 squared is 4. So I would go 4 up. Last one, if I went, let's do orange. If I went 3 squares out, 3 squared is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Notice that every time I do that, I did the 1 up, I did the 4 up, and then I did the 9 up. Notice that every time they also had a mirror point. So there's one at the exact same location, like a mirror on the other side of the graph. Okay. Another thing I want you to notice is every time I counted 1, 4, 9, I always went back to ground level. I went back to my vertex. Okay. So even if my graph started way down here, my shape would stay the same. I would count from the vertex, count up from there. 1, up 4, up 9. If it starts over here, I might only be able to fit 5 dots. I'm not going to put the 9s on if they don't fit. My parent function is the original, that's right here, but I will use the same pattern no matter where he is, okay? All right, let's go ahead and jump to the next page. We are not going to do every problem on these notes, okay? We're only going to do a couple. All right, I'm going to go through and fill out the red, green, and blue part first, and then we'll do all the graphs at once, okay? All right, so first thing I'm going to ask you is there anything in front for an A? Remember, in front means in front of the X. In this case, there is nothing, so my pattern is not going to change. He's going to stay 1, 4, 9. I would say, is there anything inside of the parentheses? Yes. Remember that he is a liar, so that would mean that I have a positive 4. We are going to move our graph to the right 4 spaces. Oops, I did that wrong. Sorry. We're going to go to the right 4 spaces. I would ask you, is there anything behind the squared, like after the square? There is nothing out here, so that number is a 0. He is not going to move. There's nothing happening. Okay? All right. If at any point I'm going too fast, you can pause and go again, listen to it again. All right? All right. So let's start with the ending one. I would say number 2, is there anything before the X? Nope. I'm going to use a normal pattern, 1, 4, 9. In number 2, for the red, I would say, is there anything inside the parentheses? There are no parentheses, so I have nothing happening in this A. In the B. He's a red. He's 0. There's nothing going on inside those parentheses. All right, for the last part, I would say, is there anything going on after the squared or behind the squared? And yes, he's a +2. +2 means that he is going up 2. This guy tells the truth. He's not a liar. He says exactly what he's doing. Okay? All right, moving on to number 3. Number 3, I would say, is there anything in front of the X squared? Yes, there is a negative. That negative is going to make my pattern flip. So instead of 1, 4, 9, I'm going to go -1, -4, -9. I'm just going to make all of my pattern numbers change to a negative. I would say, is there anything inside? Nope, there's no parentheses. That's going to stay a 0. And is there anything behind or after the squared? There is no number out there, so he would stay a 0 also. Okay? If you need to copy anything on this page, go ahead. We're going to go to the next page. I'll do all of the green, red, and blue, and then we'll graph. All right, I'm actually going to skip 4 and 5 for right now. Let's talk about 7 and 6. All right, so starting with green, I would say, is there anything in front of the X squared? Yes. A 2 is going to make me very narrow, and it's going to double my patterns. Let me zoom that in real quick. We're going to take 1, 4, 9, 1, 4, 9, and we are going to double them. So we're going to multiply them all by 2 because I have that 2 number. 1 times 2 is 2. 4 times 2 is 8. 9 times 2 is 18. Most of the time you will not use the 18 because it's too big to fit on the graph. Okay. All right, when it comes to the red for number 6, I have no parentheses, so there is nothing happening. That's going to just be a 0. If I asked you the blue, is there anything behind the X squared? That would also be nothing. There's no number there, so I would just say 0. Moving to number 7. Number 7, I have a 1/2. That's going to make my graph fat. It's going to make him wide. So this is a little bit tricky. we are going to have to cut all of these numbers, 149, in half. Okay? So if I cut this, divide it by 2, cut it in half, that gives me 0.5. If I take 4 and divide it by 2, cut him in half, that gives me 2. If I cut 9 in half, and you're going to have this memorized because you're not going to have a calculator when we do this, that gives me 4.5. Now, all of those are really small. That means that we can fit some more on here. If you think about where 149 comes from, remember that's 1 squared is 1, 2 squared is 4, 3 squared is 9. So we're used to these numbers. But we could actually say 4 squared is 16. And that helps me get my last point for number 7. So if I took 16 and cut him in half, that would give me 8. I'm going to have you write all of those out, okay? All right, when it comes to number 7, there are no parentheses. I will use a 0. And for the blue, there is nothing after the squared, so he would also be a 0. Okay? All right, we're going to graph a couple of those before we do the last page, okay? All right, I'm going to have you go back to the first page. This one with the tables on it, okay? Not the original, sorry. All right, I'm going to go to black because that's just my basic graph color. And we're going to figure out not only where to start, but also what our pattern is. Okay, so I'm on number 1. On number 1, my equation has to move my graph to the right 4 spaces. This is going to be my vertex. So my first point is going to be on 4, 0. My 149 is going to tell me where the rest of my dots go. So if I zoom in, remember I'm going to use the same purple colors. If we go out 1 space, I'm going to go up 1 space because 1 squared is 1. Switch to pink. Remember that 2 squared is 4. So if I go out 2 boxes, I'm going to have to go up 1, 2, 3, 4. And I'm going to do the same dots on both sides. Okay, both of these are the same mirror of each other. Going to 9, remember that 3 squared, if I go out 3 boxes, I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to do the same thing on the other side, like a mirror. Once I get all my dots drawn, I'm going to connect them with my parabola, that's that curve, and I definitely am going to make sure there's arrows on the top. You need to have the arrows. If you don't give me arrows on a quiz, you are not going to get full points, okay? All right, if you need to pause the screen to copy that, go ahead. We're going to move to the next problem. All right, let's look at number 2. Number 2 told me that my equation is going to start 2 spaces up, so my vertex is going to be at 0, 2. We are following the same normal pattern, so out 1, up 1. I'm going to put the 1 dot on both sides. I'm going to use my next number, which is 4. So if I go out 2 spaces, 2 squared is 4. 1, 2, 3, 4. Now, I can't go up 9 spaces because my graph only goes to 10. So that is all of the pieces that I can fit on my graph. I am just going to make sure not to cross this third line. Okay, so when I draw my graph, I have to stay inside of those third lines because I cannot cross over them, okay? I don't really need the X's there. I just wanted you to know not to cross it. Okay. All right, if you need to pause the screen, do that. We're going on. This is the first time that our pattern changes. We have a flip on this one, okay? All right, our vertex did not move, which means I am going to start at 0, 0, just like normal. But this time, when I move, I'm going to make sure that I'm moving negatives. So -1, -4, -9. So I still go out 1 space, but now I'm going to go down 1. I'm going to make down 1 on both sides. When I do 2, I'm going to go out 2 just like before, but now I'm going to go down 4. 1, 2, 3, 4 on both sides. Last time, I'm going to go over 3, out 1 more row, and then down 9. 2, 3, 4, 5, 6, 7, 8, 9. And I put that dot on both sides. One more time for emphasis, make sure when you draw your parabola that you are putting arrows on the bottom. Both sides need arrows. Okay. All right, if you missed anything on this page, you could pause it and copy it. Otherwise, we're moving to the next page. All right, I'm only looking at 6 and 7, so I'm going to zoom into just them. All right, on number 6, we're still starting at 0, 0. This one's going to be narrow, though. So remember, your pattern has changed, and you're doing 2, 8, 18. Let me zoom in a lot for this one. I'm on number 6. If I go out 1, now I have to go up twice as far. So I'm going to go up 2 dots. Okay, so I'm going up twice as far. When I do my next one, out 2 is usually 4. So 1, 2, 3, 4. But I'm going to go up twice as far. So 5, 6, 7, 8. Those are the only dots that are going to fit on this graph. So these are the only ones I can make. I'm going to go ahead and draw my parabola. Make sure that you have arrows on the top. That is my graph for number 6. Number 7, let's do the same thing. I still start at 0, 0. But now my numbers are going to be wide, so I'm using these guys. I'm going to go up a half. This is going to look really weird. Let me kind of zoom in for you. When I go out 1 box, I'm only going to go up halfway. I'm not even to the top of the square. I'm just going up halfway on both sides. When I go out 2, I usually go up 4, right? But now I'm only going up halfway. So I'm going to go up to 2. For 3, usually I go over 3 up 9, but now I'm only going halfway. I'm going to go up to 4.5. 3, 1, 2, 3, 4, and a half. So only halfway on that next one. And the last one I haven't really used. That one will make them green, I guess. Now when I go out 4, I have to do one more set of dots. Half of 16 is going to be going up to 8. All right, I know that's a lot of points, but we do need all of them, okay? Anytime you see a 1/2, you just kind of accept that you're going to give extra dots. Make sure you have arrows on the top of both, okay? All right, if you missed anything for 6 or 7, go ahead and pause it. We're going to have one more page. I am not going to do a lot of them. I think I'm just going to do 2, maybe even just one of them. Yeah, let's just do 1. All right, we're going to do 8 together all the way through. Number 8, can you add a little 2 right here? I know there's not 1 in your book, but can you put a little 2 before the parentheses here? Perfect. All right, so full problem, here's what it would look like. I would say there is a 2 in front. That's going to make me narrow. I like to write out 149 and remind myself that I am multiplying everybody by 2. That's going to be 1 times 2, 4 times 2, 9 times 2. I leave the 18 on there. Maybe we use it, maybe we don't, but at least I know what it is. Second thing I look for is who is inside. Well, I have a 3, and that 3 is a liar. So if he says -3, he's going +3. Last thing I look for is who is after the squared, who is behind the squared, and that's this +1. He tells the truth. So when he says +1, I'm going up 1, +1. All right, moving to the graph. That 3, 1 to the right, 3 up 1, he tells me where I'm going to put my first point. So 3, 1 goes right there. Following my pattern, I'm going to go up 2, up 8, up 18. So let me zoom in. I go out 1, up 1, but I'm going up twice as far. So now I go up to 2, and I'm doing that on both sides of the dot. Oops. When I do pink now, out 2 spaces, I usually go up 4, but now I'm going up twice as far. So 5, 6, 7, 8. And I do that on both sides of my graph. All right, I obviously cannot go up 18, so we are done. Connect your parabola. Make sure you go all the way to the end of the graph, and then put your arrows on the end. If you need to copy anything for problem 8, go ahead and do that now. Otherwise, we are done with this video. Good luck on 9.3. Make sure you're ready for the quiz. We will not be using a calculator on this.